Okay, we should be live. Go check out biomedical.com. Let's get that out the way. There's lots of interesting tools. Don't forget to provide your feedback. That's usual spiel. Okay, I can hear myself. Okay, so that's fine. Let's jump straight into development. We want to do a simulation of a cochlear implant. This particularly will focus on the signal processing part. It will be something similar to that, but interactive. So we have prompts in GPT-4. Actually, potentially found a better way of interacting with GPT is by like line by line kind of stuff. So we were interacting with GPT-4 through the GitHub Copilot. Meant to be GPT-4, but we not entirely sure. Might be its own model. Oh yeah, the implementation of that model is quite important, so it could be its own thing. It does behave differently, that's for sure. So we asked doing cochlear implant simulation, generate code. The Flask application rely mainly on JS. Yeah, so we wanna just to save some electricity cost. This project is not fully funded just yet, so bear with me. And that's why I need to go visit biomedical.com, because you'll be helping out the project that way. What else we got? Use microphone. Pre-recorded voice is right, so you can either use a microphone or have a pre-recorded voice or audio being processed by the cochlear implant. Display sound wave, display spectrogram of the sound. That should be straightforward. We did it before. We have applications where we do it for EEG. In this case, we're doing it for sound. That's time series. That shouldn't matter too much. And by the way, I might actually come up with something more efficient for this application, because currently it's taking too much resources. It's working well, but yeah, it's actually not even working well because it's sometimes lagging. Yeah, if you scroll too much, probably have to limit the window size and things like that. Now it's much quicker, so there's just too much stuff happening on this chart where the spectrogram is. So hopefully, and from memory, this thing is retrieving stuff from the server. We actually don't like it. So might wanna change that. By the way, sorry for jumping around. That's important for the editing of this video later. We have like a game of life simulation going. It's just a fun weekend project, but actually can be quite useful, because you can yeah, modeling, life is must be related to biomedical engineering as well, but just something a bit more fun. This one does rely mainly on JavaScript. We have model of, what happened there? I don't know. Yes, sometimes it's this funny business where you move the mouse without clicking. It's generating stuff. So we have send. Send behaves really well. It's pretty nice. Then we have water. Yeah, water behaving really well in the way it flows. However, later, for whatever reason, it just disappears. So it's not filling the void. We have rock as well. So for example, if we place a rock structure there. It should get filled up by water, but it's not filling. Yeah, fine. So the code was created by GPT-4. There's a lot of examples of game of life. Yeah, so in theory, if we create something like this, it should get filled by water, and then it should start overflowing as such. This is not quite happening yet. What else? And of course, we have a life at the moment. Yeah, so it meant to be following the the game of life stuff. If you don't know what it is, go look it up. There will be a lot of examples. Yeah, but currently it's not actually behaving properly, so I have to check the code. Might do it another time, but just a plug for another potential tool. And what else? Right, so that's the game of life. Let's close it for a sec. It should stop running. Yes. Yeah, let's open and have a Visual Studio Code window. Open folder. Yeah, this should be called Cochlea Sim or Simulator. Currently have only 2 files. Yeah, so that one is an interesting thing, because it's just another way of interacting with GPT. And we have yes, we have spectrum on the sound. Yes, for example, over here we were essentially having the same thing as for the prompt, but you can interact with it on the fly, which is just really good. Interact. So what are the components of the Cochlea implant? Consists of 2 main components: speech processor, internal implant, blah 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 blah. So yeah, you can go look up Cochlea implant. I won't be covering the basics. I did my PhD on Cochlea implant, so I should be competent doing this. Right, so we copied the same prompts. Have an option to activate multiple electrodes. Yes. Yeah, it added a bunch. Yeah, when it's adding stuff, it's just like repeating itself over and over again. Flask application details. What's that all about? Yeah, electrode array, output auditory nerve, blah blah. Can display on the same page. Yeah, I want to display everything on the same page. Sometimes it defaults to having separate HTML pages. User interaction needed. Yeah, so I guess primarily the interaction will be with the interaction will be with the sound, the input sound. Play pause. Yeah, I'm not sure about that. Ideally, just interact using a microphone. Can the simulation be turned into right? And the output of the simulation, we want to turn it back into sound as well, so you can essentially hear what potentially a patient with a cochlear implant might be hearing. Can be converted. You listen to the sound. Yep. It can be all done in JavaScript. Yeah, I think this is a bit of a stretch. It says yes, can be. So JavaScript can generate sound. Yeah, spectrogram, maybe. Electrode array, yeah, we need like some sort of drawing for it. What else we've got? Output of the turn nerve and output of the brain. So yeah, I'm not sure if we might so for example, we can shall we use the pre-trained model? Is there a pre-trained? Is there a pre-trained model? Auditory nerve printer model can be used to calculate response of auditory nerve. But is the one how to simulate the output of the brain? A model of the auditory system. Yeah, it's all makes sense. It's been trained on all these cochlear implant papers. Shall we use a pre-trained model? Yeah. So this way it just starts repeating over itself. Can never see. No, there's no other options. My question actually was, shall we stop? Yeah, the auditory nerve is interesting. Yeah, so it's the each one of those will be its own application. So it gets quite complicated. Yeah, shall we stop? No, we should simulate the output of the brain. No, don't stop. Keep going. The output of the brain is important to understanding the cochlear implant effect. Yeah, it got a point. Yeah, how to simulate the output of the brain without the cochlear implant. Yeah, that will be very interesting. But using the model can be calculate response to the brain signals generated. Using model auditory system response to the brain without a cochlear implant. Yeah, it just keeps repeating. To simulate the different electric configurations. Yeah, that's going places already. Shall we stop at the electrode array? We'll probably say no. We should simulate the output of the auditory nerve and the brain as well. Okay. To begin with, yeah, because we need to start somewhere, right? Still saying no. How about if we change it to yes? We should start simulating the output of the electrode array. Yeah. So obviously you can, yeah, still controlling the board. Luckily, it's not getting unplugged and start chopping people. The output of the electrode array is important understanding the cochlear implant simulates the auditory nerve. Yeah. So yeah, we might do that at this stage. Okay, let's go. GPT-4. It started with some JavaScript example already. So need a simple blah 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 blah. Yeah, here for example. Generate the files and folders. Run the following commands. Yep, we already have. Install the required packages. We must already have them. It's interesting because when you ask if you ask in the chat, we'll actually have a link to the bash a command window, which is nice. Which is very nice. Oh, I did create enough. Messing up my folders, isn't it? Because I needed the yeah, we are in the correct folder. Yeah, we don't need that. Right. Yeah, want most of the stuff in the JavaScript. Let's read this quickly, and I've been talking too much.
Based on your
Already
requirements
anyway.
for a simulation tool of a cochlear implant, CI, that processes audio and visually represents the processing stages, here's a high-level approach on how to structure the Flask application and a brief guide on how to implement each component using JavaScript, JS, HTML, and a bit of Python where necessary. High-level structure. 1. Front-end, HTML, CSS for layout, JavaScript for real-time audio processing and visual updates. 2. Backend, Flask server to serve the web pages and handle file uploads. Optional Python backend processes for intensive computations if needed. 3. Data flow, use the Web Audio API for real-time audio input from the microphone or file upload. Process audio data in JavaScript, dividing into frequency bands, detecting envelope, and simulating electrode activation. Use Canvas or SVG in HTML for visual representations. Detailed components. 1. Web Audio API setup. Capture audio from the microphone or upload pre-recorded files. Create an audio context and a stream source. 2. Audio processing. Implement a bandpass filter bank to split the audio into multiple channels, representing different frequency bands. For each band, detect the envelope of the audio signal, which simulates how a cochlear implant processes sound. Simulate the amplitude compression typical in cochlear implants. Visual representations display the waveform of the sound. Show a spectrogram for detailed frequency analysis. Visualize the filter banks and the response of each electrode in the array. Dynamically show the activation of electrodes based on the sound input. 4 additional interactive features allow users to manually activate, deactivate electrodes to see the effect on the processed sound. Option to synthesize back the audio from the electrode activation patterns requires complex signal processing and synthesis algorithms. 5. Flask server setup. Serve the static files and HTML pages. Handle audio file uploads. Optional, if real-time processing in JS isn't feasible for some heavy tasks, implement these in Python and call from JS. Example, JavaScript code snippet for audio processing. Here's a basic setup to capture audio and create a processing node. JavaScript const audio context equals new audio context. Let audio source navigator.mediaDevices get user media audio true. Then stream audio source equals audio context.create media stream source stream. Const processor equals audio context.create script processor 256.1.1. Processor.onAudio process equals function e. Let input equals e.input buffer.get channel data 0. Process audio data here. Audio source.connect processor. Processor.connect audio context destination. Here visualization with Canvas. Here's how you might set up a canvas to visualize the sound. JavaScript const canvas equals document.getElementById audio canvas. Const ctx canvas.getContext 2D. Function draw, request animation frame draw. Clear previous drawing ctx.clearRect0, canvas.width, canvas.height, / visualization code here. Draw. For more complex parts like synthesizing sound from electrode activations or setting up the filter banks, you can use prompts like generate JavaScript code to simulate bandpass filter bank for audio processing. How to create a dynamic range compression in JavaScript for audio signals. This setup gives you a good starting point. Depending on the complexity and performance requirements, you might need to adjust or offload more processing to the server side.
Yeah, I was just asking GitHub Copilot to generate a template that's not complete, is it? This is more like it. More like it. Generating template for index HTML, and then we go to the JavaScript code. Yes, static main.js, that's correct. We'll ask GitHub Copilot, but then we have something from GPT-4 as well. It's suggesting a new page. We don't want a new page. Yeah, that's just weird. That is... No, what? Doesn't make any sense. No, I was regenerating the HTML code. Workspace, you can use the following JavaScript to capture audio and process it. Kinda similar to what the GPT-4 generated as well, doesn't it? Declaration was marked as deprecated. It's not good. That's exactly the same. How come? It's just taking some existing example. audio worklet interface instead. Audio worklet. Worklet's really weird name. It's giving us some prompts for Copilot. So that's in JavaScript. Generating the script code to simulate bandpass, filter bank for audio processing. Dynamic range compression. Okay, we have some frequencies. Bandpass is fine, even though the first one could be. Wait, they're all bandpass? Yeah, we'll get to it in a sec. Something actually displayed on the HTML. Okay, we need to allow microphone, and nothing is displayed. Must be an error. After user gesture, okay, doing a gesture on the page. Want to a JavaScript 38. Canvas get context 3D. Let's do them one by one. Let's do them one by one. Do this call that could have an HTML element. Yes, need to regenerate the HTML, don't we? Let's add event listener. Have 45 lines of code. Right, we added an event listener. Yeah, we need to change the. Can we just go update with workplace? Update the HTML code based on the recent changes in the JavaScript. Yeah, so it's determining workspace structure and deciding which. Yeah, we need an audio canvas. Audio canvas. The user aborted the request board. Didn't abort anything. I didn't do anything. Again with workspace. Yeah, policy of the browser. Okay. Yeah, we need a start button. Can we have a different type of interaction? Guess that will be the Easy peasy. Fix start button, save event, add event listener, get element by ID, the start button goes somewhere here. Assignment to constant variable. We can assign to constant variable. That's why we need that. Create media. Okay, we're obviously missing stuff. Create media source is undefined. Generating the whole code? No. No, it is. 57 lines, and this one 50. Should be okay. One, two. I have some sort of simulation. Is that? That's the correct microphone. One, two. No, it's just taking the microphone, doing something with it. That's okay. With all the drawing. Get user media. And get the media devices. Where does that go? Yeah, just Why? Okay, let's do the audio processing. Okay, vad händer? Va? Yeah, 51 undercode. Can I 63? 1, 2. 1, 2. Okay, it's fine because this microphone is not filtered, so you can hear noise from the outside and stuff. Focus is that one. You see a graph that shows electrical signals being sent to the brain. Yeah, that's quite ambitious, isn't it? What's the timing out? Pretty sure it's timing out. let's do 2 and 3. With a workspace handle. See if it can improve the code. We're obviously missing visualization. Pretty sure it will have trouble. Yeah, it has all these follow-up question options, which are quite handy. So how can we implement the bandpass filter bank using the web audio API? Don't we already have it? Yes, we do. Yeah, we're connecting filters in a series. It should be fine. How can I detect the envelope of the audio signal using a web audio API? Oops. Navigate media devices. Create a gain node, create a wave shaper for the envelope follower. Set the curve for the wave shaper. I'm not sure about that. Yeah, I don't know about that. Let's go back to we have HTML and JavaScript. Just go from here, see what it says.
Your code lays a good foundation for the cochlear implant simulator application using Flask and JavaScript. Here are a few enhancements and corrections to ensure your application runs smoothly and efficiently. HTML and Flask. Your HTML and Flask setup seems correct. Ensure the main.css and main.js files are appropriately placed in the static directory of your Flask project. JavaScript enhancements. One connection of filters and processors. Ensure each filter connects not only to the next filter, but also appropriately to each component, envelope followers, compressors. Your current chaining might miss some connections, leading to some filters not properly being processed. Number 2. Envelope followers. The current setup for the envelope followers doesn't actually process any audio signal. You need to ensure the rectifier shapes the signal. You can use a simple function for full wave rectification, and then it should be passed through a low-pass filter. 3. Visual feedback. For visual feedback, such as the activation of electrodes, consider adding visualization code within the draw function that uses the processed audio data to update the canvas. This requires storing the audio data or metrics in a globally accessible object. 4. Audio worklet. Good initiative using audio worklet for more complex processing. Make sure processor.js contains the appropriate processing class, which isn't currently included. This file is crucial for handling more advanced audio processing tasks. 5. General improvements. Add error handling, particularly for the media devices and audio context setup to manage exceptions or errors gracefully. Consider the asynchronous nature of JavaScript, ensuring that resources are loaded and connected in order. Hashnerd, sample updated JavaScript code. Here's a more refined approach to setting up your audio processing chain, focusing on corrections and additional clarity. JavaScript document.addEventListener DOM content loaded event equals let audio context equals new audio context. Let audio source document.getElementById.addEventListener click async. Try. Const stream equal wait navigator.mediadevices.getUserMedia. Audio true. Audio source equals audio context dot create media stream source stream. Const filters. Const frequencies equals 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Frequencies dot for each frequency equal. Const filter equals audio context dot create biquad filter. Filter dot type equals bandpass. Filter dot frequency dot value equals frequency. Filters dot push filter. / chain filters and other processors. Filters.reduce equals prev.connect cur return cur. Connect final filter to destination filters like connect audio context to destination, audio source.connect filters 0. Add visualization function calls visualize filters audio context. Catch error console.error error accessing audio media error. Function visualize filters audio context. Const canvas equals document.getElementById audio canvas. Const ctx equal canvas.getContext2D. Function draw, request animation frame, draw, cx.clearRect00, canvas.width, canvas.height. Add visualization based on filter data, draw. Final notes. Ensure all dependencies such as CSS and JavaScript files are correctly linked and that your Flask application's structure supports static file serving. The audio processing and visualization logic can get complex, so make sure to test each part incrementally to ensure everything integrates seamlessly.
Now, there should be a way of working this thing. Because it's obviously it's much better. Sometimes it's better than Copilot. Is everything meant to be summing up. To regenerate the whole code. One, two, one, two. Yeah, obviously nothing works. I'm just adding a functionality to the code using prompts from one bot so the other can code. Get suggesting a class contains appropriate processing. Well, that's what the prompt asks for. Okay, we also need to do error handling, and some functions probably can be asynchronous. We don't have any. Yeah, we only have the draw function. It's probably incomplete. We only added that button because we need an interaction with the application for the sound to work. So that's obviously using try there and then catch. Yeah, might need to regenerate the whole code. Yeah, it's probably GPT-4 doesn't need the help from Copilot. Can you regenerate the complete updated JavaScript code? This is what I currently have. But this code requires total refactoring.
Certainly. I'll help refactor your JavaScript code for the cochlear implant simulator. The aim here is to ensure that your audio processing pipeline is both efficient and well organized, making it easier to maintain and extend. Refactored JavaScript code. I will streamline the existing code by organizing the setup into functions and improving the clarity of each step, ensuring a more modular approach. JavaScript document.addEventListener DOM content loaded. Const audio context is new windowed audio context window.webkit audio context. Const canvas equals document get element audio canvas. Const ctx canvas.get context. Let audio source, let filters equals, let envelope followers equals, let compressors, document get element by id start button add event listener click async. Try const stream equals await navigator media devices get user media audio true. Audio source equals audio context create media stream source stream. Set up audio nodes, connect audio nodes, load audio processor, visualize, catch error, console.error, error initializing audio processing, error. Function setup audio nodes. Const frequencies equals 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Frequencies for each frequency equals const filter equals audio context create biquad filter. Filter type equals bandpass. Filter frequency value equals frequency. Filters push filter. Const compressor equals audio context create dynamics compressor. Compressors push compressor. Const rectifier low pass equals create envelope follower. Envelope followers push rectifier low pass. Function connect audio nodes. Filters for each filter index equals if index 0 filters index -1 connect filter. Filter connect envelope followers index rectifier. Envelope followers at low pass connect compressors index connect audio context destination. Audio source connect filter 0. Function create envelope follower. Const rectifier equals audio context create wave shaper. Const low pass equals audio context create biquad filter. Low pass type equals low pass. Low pass frequency value equals 10. Adjust as needed. Full wave rectification curve rectifier.curve equals new float 32 array 22 keys map I equals const x equals I minus 25 11 25 return 3 plus x by 3 plus math.
Modular functions, each part of the audio processing chain, creating nodes, connecting them, loading processes, is now handled in separate functions. This improves readability and maintainability. Setup and connection. I've encapsulated the setup and connection of audio nodes into specific functions, ensuring that each node is properly initialized and connected in a structured manner. Envelope follow curve. The curve for the envelope follows rectifier is now set up to perform full wave rectification using a calculated curve, which is crucial for accurate envelope following. Visualizations. While placeholder comments are still in place, you should implement specific visualizations for each part of the audio processing in the visualize function, reflecting the actual audio processing states. Error handling. Improved error handling, particularly around the initialization and media access stages. Activity calculation. To make the visualization meaningful, you need to replace the placeholder math, random, calls with actual metrics or signal processing data extracted from your audio processing pipeline. User interface, UI, considerations. Make sure the canvas size is adequate for the number of filters and stages you are visualizing. You might need to adjust the bar width and spacing based on the actual number of filters. To address the initial error, ensure you initialize and resume the audio context inside a user-triggered event, like your button click handler. Here is how you might adjust the initialization. Ensure processor. JS contains your audio workload processor class with the appropriate processing logic as outlined in your original code. This script needs to be properly linked from your server to be accessible by the client browser.
Okay, can we redo this function? Without any additional JavaScript code. In other words, we only have one JavaScript code file. Yep.
Certainly, you can include all your JavaScript functionality, including the load audio processor function, in a single JavaScript file. To do this, you simply need to ensure that the function is defined within the same script and properly integrated into the overall flow of your application. Below is how you can structure your entire script with the load audio processor function included, making sure everything is well organized and executed in the correct sequence within your single JavaScript file. Yeah, already have visualization logic. Yeah, one way to do this is go over the comments. Yeah, just taking it from the bottom there. So that should be complete code. One. Notice still calling another JavaScript function. Why? I asked it not to.
Yeah, I want to keep it simple.
Audio context initialization. The audio context is now initialized within the user-triggered event to comply with browser autoplay policies. Module loading. Load audio processor is part of the same JS file and is called within the button click event flow after setting up and connecting the audio nodes. Error handling. Added error handling for the module loading to catch and log failures. This single file approach keeps your client-side scripting consolidated, making it easier to manage and debug. Just ensure that your server serves processor JS correctly and that it contains the necessary audio workload processor code for processing audio.
Can we rewrite the load audio processor function to not use any external JavaScript code? Everything should be contained in this one file. Yes, you can. However, due to the limitation of audio worklet, you need to use a blob and URA create object URA to create. That's not good. It's rewriting the whole thing.
To include all your JavaScript functionality in a single file without relying on external scripts like processor JS, you need to adjust the implementation to handle audio processing directly within the main script. Since browsers typically require audio workload processor code to be in separate modules due to their execution in a separate context, this constraint means you cannot directly include an audio workload processor in the main script. However, you can use other web audio API nodes for processing or create simple JavaScript functions to mimic some audio processing tasks directly in the main thread. Here's how you can adjust your script to include basic audio processing without audio workload processor. To include all your JavaScript functionality in a single file without relying on external scripts like processor JS, you need to adjust the implementation to handle audio processing directly within the main script. Since browsers typically require audio workload processor code to be in separate modules due to their execution in a separate context, this constraint means you cannot directly include an audio workload processor in the main script. Removed audio workload. This script no longer attempts to load external modules and instead uses the available web audio API nodes directly. Simulation using gain nodes. Gain nodes are used to control the output level of each filter path. This setup is simplistic but allows for volume adjustments, mimicking some level of dynamic control that might be achieved with more complex processing. Visualization and control. You could further expand the visualization based on the levels of each gain node or the outputs of the compressors. To ensure that the sound from the microphone is processed effectively in your JavaScript code using the Web Audio API, you need to correctly set up and connect all the audio nodes in the chain, from the audio source, microphone input, through various processing stages, filters, envelope followers, compressors, and finally to the destination, audio context output. From the code you've provided, it appears you have a good structure in place. However, let's make sure each part is correctly implemented and functioning as expected. Capture and stream microphone input. You already have code to request access to the microphone and create an audio source from the stream. It's essential to handle the promise correctly and catch any errors. Dynamic node connection. Your chain setup must ensure that each node is correctly connected. For example, after creating each filter, envelope follower, and compressor, they must be linked in the correct sequence. Filter and compressor settings. Ensure that your filters and compressors are configured with settings that are effective for the sound characteristics you expect from the microphone. Misconfiguration could lead to no sound being processed because the filters may not pass the incoming frequencies. Visual feedback. Implement visual feedback, as you did with the visualize function, to help debug and confirm that the audio is flowing through the node chain and being processed. Watching real-time changes on the canvas can help diagnose issues like nodes not receiving audio. Testing and debugging. Regularly test with console logs or by examining the states of various audio nodes, like checking the audio context state. If the context is suspended or closed, the processing will stop. Utilize audio context resume method properly within user-initiated events to handle browsers' autoplay policies. Error handling. Always include error handling when working with asynchronous operations, especially when accessing hardware resources like a microphone. This helps in diagnosing if permissions are denied or devices are not available. You already have code to request access to the microphone and create an audio source from the stream. It's essential to handle the promise correctly and catch any errors.
Yeah, just using Copilot to figure out what's going on. Doing this cochlear implant model. Yeah, we have a few problems. Quite a few. I want to make sure the microphone is working correctly. Don't think it is.
Your chain setup must ensure that each node is correctly connected. For example, after creating each filter, envelope follower, and compressor, they must be linked in the correct sequence.
Seems there is a small mistake. The filter should be connected to the compressor. Still connect the audio nodes. Don't think this was changed.
Ensure that your filters and compressors are configured with settings that are effective for the sound characteristics you expect from the microphone. Misconfiguration could lead to no sound being processed because the filters may not pass the incoming frequencies.
That's interesting. We already have a bandpass audio filter. Yeah, that's the same. Yeah, we're still trying to test. Okay, visual feedback.
Implement visual feedback, as you did with the visualize function, to help debug and confirm that the audio is flowing through the node chain and being processed.
Don't think it
Watching
is.
real-time changes on the canvas can help diagnose issues like nodes not receiving audio.
It's getting something, but it's either moving too fast potentially for me to see the changes because I talk too slowly or something. Okay, we have a visualize function. No, it just does a random thing. Yeah, we don't want to do random stuff, do we? One. Okay, that's not working at all. One, two.
Regularly test with console logs or by examining the states of various audio nodes, like checking the audio context state. If the context is suspended or closed, the processing will stop. Utilize audio context resume method properly within user-initiated events to handle browser's autoplay policies.
Oh, that there is okay. Don't care about that. One, two. Okay, this tool might be taking quite a few sessions, which is fine. But that doesn't seem to be and nothing is being displayed. Microphones seem to be connected okay, but I don't see any envelopes or the sound amplitude. Should be fairly simple. Get stuck. Yeah, we got to. We're asking for too much to begin with, and now we trying to fix the little things. Yeah, we need more debugging. If everything is being called correctly. One, two. No. Some sort of initialization. Problem, is it? At, why is this still running? By the way, time to mention, go check out biomedicals.com. You'll be supporting the project that way. One. Visualization is called filters at the not sure about those. Just this just collapsed on me. It did, didn't it? Okay, I think we might need pop the whole code GPT. The bot to fix it. visualize is called okay. Get rid of the console log. It's not actually helping. One.
To make sure the sound from the microphone is processed in your JavaScript code for cochlear implant simulator, let's review and refine some parts of your code to ensure effective real-time audio processing and visualization. Initiate audio processing properly. It looks like the initial steps are correctly set, but let's make sure the audio nodes are properly connected for effective sound processing. Visual feedback and processing updates. Your visualize function is set up to repeatedly call itself using request animation frame, which is good for real-time updates. However, creating a new analyzer node on every call is not efficient and could lead to excessive resource use. Instead, create analyzer nodes once during setup and reuse them.
To change the code. Teach me. Okay, the start button. Try audio context. Try navigator. Do want to the sampling rate so high? Snap. Oh, snap. Problem with a visualize HBA. You're not creating new analyzer node and very cool. Should help with performance. Yeah, we can definitely use a better performance. 1 2 1 2 1 1 1. Have something happening. But yeah, it's meant to be processing the microphone. One. So I want to use a main microphone, something out of bounds.
Use of analyzer nodes. To provide real-time visual feedback based on the microphone input, analyzer nodes should be integrated into your audio node chain properly, and the data should be used effectively in the visualize function.
To fix that, node chain, microphone input. Yeah, I don't think we're using the microphone input. It's unbelievable that most of the time is just spent on, this little tiny bits and bobs. Don't like it. Connect the filter. Should remove the line where the filter is connected to the analyzer because it's already done. So we're not doing it in visualize. This way, not change that is used effectively in the visualize function. Okay. One. No. Did it regenerate a whole code? I didn't ask it to, but okay. I thought we have Copilot doing the actual coding. Then Copilot is also struggling.
Analyzer setup. Analyzer nodes are now created during the initial setup and connected to each processing chain. They're used to gather real-time data for visualization.
This is obviously missing stuff. We can comment everything out so we have it at the bottom. The new code, yeah, obviously that's incomplete. One. I don't know what is it doing to move on.
To make sure the sound from the microphone is processed in your JavaScript code for the cochlear implant simulator, let's review and refine some parts of your code to ensure effective real-time audio processing and visualization. Improvements and checks. Initiate audio processing properly. It looks like the initial steps are correctly set, but let's make sure the audio nodes are properly connected for effective sound processing. Visual feedback and processing updates. Your visualize function is set up to repeatedly call itself using request animation frame, which is good for real-time updates. However, creating a new analyzer node on every call is not efficient and could lead to excessive resource use. Instead, create analyzer nodes once during setup and reuse them. Use of analyzer nodes. To provide real-time visual feedback based on the microphone input, analyzer nodes should be integrated into your audio node chain properly and the data should be used effectively in the visualize function. Analyzer setup. Analyzer nodes are now created during the initial setup and connected to each processing chain. They're used to gather real-time data for visualization. Optimized visualization. The visualization now uses the data directly from the analyzers, providing accurate feedback on the processed audio signal. Error handling. Error handling for microphone access and audio context is structured to provide clear feedback. This code optimizes the performance of your audio processing and visualization, ensuring that it functions correctly and efficiently.
Your code looks like a solid start to creating an interactive simulation using p5.js and integrating it into a web interface with Flask. Here are a few technical suggestions to further optimize and improve the functionality. JavaScript and p5.js enhancements. 1. Efficiency in grid updates. You're currently copying the entire grid to temp grid for every update, which can be optimized. Instead of copying over unchanged elements, consider directly updating grid in place where possible, and using a flag to keep track of changed cells to minimize unnecessary computations. 2. Improved water and sand physics. Your current implementation handles basic downward and lateral movement, but doesn't account for pressure or velocity, which could make the simulation more realistic. Consider adding momentum to the sand and water particles so they continue to move in a direction until stopped by an obstacle or slowed down by friction. 3. Dynamic frame rate. Instead of a static frame rate, you might introduce a dynamic frame rate that adjusts based on the complexity of the current scene. This would make the simulation run smoother by allowing faster updates in simpler scenes and slowing down when more computation is needed. 4. Optimization with web workers. For more complex simulations, consider offloading calculations to web workers. This would prevent the UI thread from being blocked during heavy computations, thus keeping the interface responsive. HTML CSS adjustments. 1. Responsive design. Make sure your canvas and control panel scale properly on different devices. Using viewport units, VW, VH, and media queries in CSS can help ensure that your application is usable on both desktop and mobile. 2. User interface improvements. Enhance the user interface by providing feedback on selected materials and current grid size. Visual cues or a preview of the material can improve user interaction. 3. Accessibility. Improve accessibility by adding area labels to form elements and ensuring that all interactive elements are keyboard accessible. Flask app enhancements. 1. Template integration. Ensure that your Flask app is correctly serving the p5.js scripts and CSS. It's important that the static paths are set up correctly in Flask to serve these files without issues. 2. Development versus production. When you're ready to move from development to production, make sure to adjust the Flask configuration to run more efficiently and securely. This includes turning off debug mode, setting a proper secret key, and possibly using a more robust WSGI server like Gunicorn. 3. Error handling. Implement error handling in your Flask application to manage unexpected issues gracefully. This could include handling 404 errors or providing user-friendly error messages when something goes wrong. Here's a simplified example of how you might